Good morning, this is Kasturi Day. I was discussing in my last video about the question answer section of the heat chapter according to ICSE syllabus class 7. Okay, so I'll continue with the short and long questions. Okay, so first one today I'll discuss is, why does an iron chair placed in the sun feel hotter than the wooden chair? What happens, as we know that iron is a metal and it's a good conductor of heat. So when placed under the sun, it absorbs more heat as compared to the wooden chair, because wood is a bad conductor of heat and it absorbs less heat. So this is the condition when iron chair is placed in the sun, absorbs is hotter than the wooden chair. Okay, next we come to, why are the mud houses with thatch roofs cooler in summer than concrete houses? Because we know that thatch roofs contains a large amount of trapped air. It has pores in them, thatch roof, and it traps a large amount of air. And what happens? This air is a bad conductor of heat. So heat from outside is not getting inside the house and it's keeping the house cool. Okay, but on the other hand, what happens in case of concrete roof, it is a solid mass and it retains the heat for a longer time. Okay, so what happens, as it retains the heat for a longer time, it keeps the house warmer than the mud houses with the thatch roofs. Okay. Now, why does water in the ponds feel hotter near its surface than its base during the summer? What happens? Because the sun's heat heats the water of the pond, okay, on the surface through radiation, we know. And this beam of sun, which reaches the upper layer of the body, does not pass into the lower layers, because we know that water is a bad conductor of heat. Okay, and what happens, these layers so remain cold during the summer season. It takes a long time to reach the lower layer, so it remains cool rather. But moreover, cold water masses are heavier than the warmer ones, and so they settle down at the bottom, and the upper warmer areas, they remain on the top due to this convection current. Okay. Then again, a blanket keeps a person warm, but when wrapped around ice, it does not allow it to melt. Why it is so? Explain. What? Because a blanket, we know that a blanket has pores. Okay, and this pores traps air, and air is a bad conductor of heat. So this blanket, when it is used by a person to cover himself, what happens? This blanket with trapped air rather, it does not allow the body heat to escape, and so it keeps the body warm. Okay, and when it is wrapped around an ice cube or ice bar, what you to say, then what happens? This blanket will not allow the heat from outside to penetrate into the reach the ice and melt it. As we know that air is a bad conductor of heat, and so the ice does not melt. Okay. Now, next we come to the numerical section. First one is, change 176 degrees Fahrenheit to the Celsius scale and Kelvin scales. Okay. Now, Celsius scale C is equal to, we refer to the formula 5 by 9 into F minus 32. Then C, that is Celsius scale. So, 5 by 9 into 176 Fahrenheit we can write 176 minus 32, that is 144. So, 5 by 9 into 144, that gives us 80 degree centigrade. Okay, this is the Celsius scale. Now, Kelvin scale, when we convert it to Kelvin scale, what happens? Kelvin is equal to, K is equal to 273 plus C. So, 273 plus 80, we get 353 Kelvin. Now, the temperature of a room is 77 degrees Fahrenheit, what would be the temperature in the Celsius scale? Again, we come to the same formula. C is equal to F 5 by 9 into F minus 32. 5 by 9 is equal into 77. In place of F, we put the value of F, that is 77. 77 minus 32, that is 45. So 5 by 9 into 45, that gives us 25 degrees centigrade. Now the temperature of a liquid hydrogen is 8K, 8000. I mean 8 Kelvin. What is the temperature on the Fahrenheit scale? So we know K is equal to Kelvin scale is equal to 273 plus C, that is Celsius scale. So C is equal to 273 minus Kelvin. Now that will give us 273 minus 8. The value of K is 8. So 265 degrees centigrade. Okay. Now we convert this C into Fahrenheit scale. Then C is equal to 5 by 9 F minus 32 into F minus 32. So we can write that 9C by 5 plus 32 is equal to F. So C, in place of C, we put the value of C, that is 265. 9 into 265 by 5 plus 32, that gives us to 509 degrees Fahrenheit. Next we come to find the temperature at which the Fahrenheit and the Celsius scale give the same reading. Where the Celsius and the Fahrenheit scale give the same reading, we have to find out that temperature, that particular temperature. Now we know that F, that is Fahrenheit, is equal to C into 9 by 5 plus 32, or C is equal to F minus 32 into 5 by 9. So to find out the temperature when both the scales are equal, we need to form an old algebra trick and just set that as the question says that Fahrenheit and Celsius scale are equal at the same reading, that is F is equal to C. So we put C is equal to F or F is equal to C, whatever it is. Then C is equal to, in place of F, we write the formula of F, that is C into 9 by 5 plus 32. So we get what? C, we interchange the position, that is C minus C into, we take the C in one side and the number on the other side, C into 9 by 5 equal to 32. So we get 5 minus 9C by 5 into 32, that is equal to 4C by 5 into equal to 32. C is equal to minus 40 degree centigrade. Now again F is equal to C. Now in place of C we put the formula of F. So the formula of C we put in place of the Celsius scale. So F into 9 by 5 plus 32. Okay. Now this way we get F minus 9 by 5, 9F by 5, that equal to 32. That is 5 minus 9F by 5F minus 9F by 5 equal to 32. Then in the same case we get minus 40 as the answer. So we see that the temperature where C and F scales are the same is minus 40 degree Celsius. Minus 40 degree where C is equal to F, that is degree centigrade is equal to degree Fahrenheit. Then we come to convert 65 degrees Fahrenheit into C, 37 degrees centigrade into Fahrenheit, 273 Kelvin into degree centigrade, and 96 degrees Fahrenheit into Kelvin. Now we move on. First 65 degrees Fahrenheit into centigrade. So F minus 32 into 5 by 9. So in place of F we put the value of F, that is 65 minus 32 into F by 9. So 33 into F by, 5 by 9, that is 18.3 degrees centigrade. Then second case, 37 degrees centigrade into Fahrenheit. So we put F equal to 9 by 5 C plus 32. 9 by 5 into 37. In place of the C we put 37. Okay, plus 32. Okay, so it is 66.6 plus 32, that is 98.6. Okay. Then 273 plus, we have to convert 273 Kelvin into C, into degree centigrade. So K is equal to 273 plus C. So in place of K, we put the value of K, that is here, it's given 273. So 273 is equal to 273 plus C. So C becomes 0 degrees centigrade. Now we have to convert 96 degrees Fahrenheit into Kelvin. So C is equal to F minus 32, 5 by 9. Then we in place of F, we put the value 96 degrees Fahrenheit, 96 minus 32, F by 9, that is 64, 5 by 9, and we get 35.55 degrees centigrade, and this we convert into Kelvin. So Kelvin K is equal to 273 plus C, that is 273 plus 35.55, that is equal to 308.55 Kelvin. Okay. For this you have to learn the formulas and practice a lot of numericals, then you will understand the formula, you will memorize the formula, and you can solve the question answers better, numericals rather. The temperatures of the body rises by 1 degree centigrade. What is the corresponding rise on the Fahrenheit scale and on the Kelvin scale? We know that C scale, that is Celsius scale, centigrade scale has 100 divisions and Fahrenheit scale has 180 divisions. So 100 degrees centigrade is equal to 100 degrees centigrade is equal to 180 degrees Fahrenheit. Okay, so 1 degree centigrade is equal to 180 by 100 in Fahrenheit. That is equal to 1.8 divisions of the Fahrenheit scale, or 1.8 degrees Fahrenheit. Okay, so 1 degree rise means 1.8 degrees rise in Fahrenheit scale. Then C scale is equal to 100 divisions and Kelvin scale is also equal to 100 divisions. So 100 degrees centigrade is equal to 100 Kelvin. So 1 degree centigrade is equal to 100 by 100 Kelvin, that is equal to 1 Kelvin. So 1 degree centigrade rise in centigrade will give a rise of 1 Kelvin. The temperature rises by 18 degrees Fahrenheit. What is the rise on the Celsius scale? Again, same way, C scale is equal to 100 division and F scale is equal to 180 division. So C scale, that is 100 degrees centigrade, is equal to 180 degrees Fahrenheit. So therefore, we can say that 180 divisions of Fahrenheit is equal to 100 degree divisions of Celsius scale. So 18 degrees Fahrenheit is equal to how much? 100 by 180 into 18, that is equal to 10 degree centigrade. Okay, so if we give a rise of temperature, if there is a rise of temperature of 18 degrees Fahrenheit, the Celsius scale will rise 10 degrees. Okay, so this is the end of the chapter heat. If you have any doubt, please write in the comment box. If you have liked the video, press the like button, and if you are a new viewer to my channel and if you have not subscribed yet, please do subscribe to get the notification of my next video. And please go through the videos to get the hold of the chapter. You can better understand the chapter and practice the formulas again and again, so that you can get a hold of these formulas. Thank you.